Okay, now, some people are asking about like interval, line, that kind of thing. For the sake of argument, when they say chord PQ, usually they're referring to the actual whole line that passes through it, okay? So, yes, when I'm talking about the chord, it's just that portion, right? But if I extend it, it really does pass through this point that's outside the parabola, okay? By the way, outside, inside, that distinction is going to become really important in a minute, right? Okay.
How's there outside, inside, not closed?
Because it's a nice convenient way of distinguishing between the two regions, which it does actually divide the Cartesian plane into. So, I mean, I suppose you could call it up and down, but inside-outside feels natural, because it looks like it. Anyway. All right, now, there's the question. What's the locus of the midpoint of PQ? Okay, now I haven't told it to you in the question, but usually you'd need to define some point, which is all of the points which are on this locus, right? So since it's a midpoint, I'm going to call it M. So let the midpoint be M. I'd usually call it P, right? But P's taken already. So M will just have to do. Okay. Now, since the locus moves around, that's why it's X and Y, and they're variable. Okay. So we're going to find out what the relationship between these two is, and that'll give us the locus. Okay. Now, you've been doing this for a little while without me. Let's see how much you've learned. What do I do? What would be your first step? I've just introduced M. What would you do? Find the gradient of what?
So you do, and then you can find the gradient of the locus.
Okay. Now, gradient's an interesting thing. It's really important with the parameter, right? Because sometimes, depending on the parameter you've got, the parameter is the gradient, okay? Now, in this case, we actually know a lot about this parabola already. For instance, what's its focal length? A equals 1, right? Now that tells you that when you've got these P and these Q points, right? The general form for any point on this parabola is, well, what is it? For each point, what are its Cartesian coordinates? 2AP, AP squared, which in our case, right, so 2P, P squared, lowercase, right? And likewise for Q, I'm going to have 2Q, Q squared. Now I'm probably going to suggest that gradient here, as an end result, won't be that useful, okay? Because I'm looking for a position more than actually how steep it is, okay? So I'm going to leave gradient off for now, even though if I wanted to, well, what is the gradient of this? Like say at this point here, if I drew a tangent in, what would its gradient be? Yeah, at P. At P. No, you don't. This is the whole point of parametrics. It's P. Thank you. That's why P is useful, or Q. Okay, because that's the gradient at that point. Anyway, that's a side point. Right. You can derive it, and it's not that hard. But here, I'm not really interested in it. It's a peripheral question to me. Okay, a trivial question. All right, let's move on. You seem to need some help. So, a locus, right? It's a relationship between these x's and these y's. Well, it would help if I knew what the x's and y's were, right? So it's the midpoint between P and Q. I know what the coordinates of P and Q are, right? So what's x equal to? If you want to find a midpoint, right? How do you find the x coordinate of a midpoint?
2P plus Q.
Yeah, you're going to take the average of these two, right? So I'm going to go half 2P plus 2Q, which, as you said, is P plus Q. Okay?
I accidentally said 2P plus Q.
That's okay. All right. What about my y coordinate? I do it the same way, right? I'm going to take these two y coordinates and I'll just take the average, right? Which is half P squared plus Q squared. Okay. Now at the moment, what I've got is the parametric equations of the locus. Do you remember this? Parametric equation of the locus? Because I've got the x in terms of the parameters, I've got the y in terms of the parameters, and that's sort of done, right? But I want a Cartesian equation, right? A single equation rather than two, because then I can work out what the restrictions will be, okay? So how do I go from two equations into one? What do I have to do? I have to do some kind of substitution, right? What would you do? If I want to get x in terms of y or y in terms of x, it's the same thing, what would you suggest? I think I should square what? The x, right? Not much use squaring this, because my p squareds and q squareds will turn into p to the 4s or whatever, right? So I square this. Let's do that. X squared, okay? That's p plus q all squared, right? So that's p squared plus q squared plus 2pq. All right, now, this is good. Well, at least it's better than what we had before, okay? But I've still got some problems, okay? You can see this p squared and this q squared, I'll be able to sub that out for this y here. It's just off by a factor of 2. Is that okay so far? Yes? But what do I do with this guy? How am I going to get rid of him? Because I can't unfortunately just subtract him, maybe put him on the other side. I've got to get rid of all my parameters, right? So what other information do I know that can help me eliminate this 2pq over here?
Well, PQ are the gradients, right?
PQ are the gradients.
Yeah, Justin work on from that.
Badass. Yeah.
No, I don't know the answer.
A very valuable contribution. Okay, think. I actually already gave you a clue. What other information do we have which can actually help us in this situation? Psst, there's not that much information given to you in the question. Yeah, these coordinates, right? They're going to figure in somehow, okay? The question is, how will I bring them into play? How will they help me?
X equals 0.
If a chord, a line, right, passes through some point, okay? That geometrically, that's what it means. But algebraically, what that means is, this chord, it has some equation, right? Okay? And that means that when you have that equation, this pair of coordinates ought to satisfy that equation. You should be able to take x equals 0 and y equals minus 2, slap it in whatever this is, and out will come something, right? Okay, now, we did discuss this before. You do have to prove these equations, but let's just move on. Does anyone remember? What's the equation of a chord, PQ? Does anyone remember? I'll give you a clue. Let's go over here. It starts with half. P plus Q, X, yeah?
Did you have to derive it in the exam anyway?
Yes, which I said 2 minutes ago. But I want to answer the question. And you guys can, I'm going to give you a sheet in a second, which is all the derivations and proofs on it.
Do you know when we derive it? Do we use the calculation form? I can't remember.
Doesn't matter. They'll both give you the same equation. Okay. I'm missing some stuff.
Minus APQ.
Minus APQ equals?
Y.
Is that right? Who's confident?
James is very
Is anyone confident? Now, is that the way I've written it?
You gave us like Y.
I usually write the y over here and the APQ over there. But it doesn't matter, it's the same equation. Let's go with it, okay? Now, there's the equation of the chord. You usually would have derived this, okay? But let's assume we've just gotten there. So it only takes a few lines, okay? What am I going to do with this? I've got to sub 2 things into here. Number 1, I'm going to sub in this point that we talked about. Okay, so there will be my x's, there will be my y's. There's something else I've got to sub in. A, which we know to be 1. Okay, so let's go ahead and do that. In this case here, A equals 1, x equals 0, y equals minus 2. Okay, so off you go. You get this. Positive 2? Minus PQ, yeah? Yes?
Where'd Y go?
Right there.
Oh, that's what Y is. That's right.
Y is minus 2. Okay. Alright, now that's helpful, because that PQ, right, that's exactly what I need to get rid of over here. Alright? So now that I have that in place, I've got all the pieces I need, sort of. X squared equals. Now, I know what y is. Y is half p squared plus q squared. So if I put that half over the other side, like so, okay? So what have I got here? That's 2y. And that is 4. Okay. There's the equation of the locus, right? Now, what we've been saying, right? Just as with the derivative of log x, okay? Just because you get an equation at the end, that doesn't mean that this is exactly the locus we're after, okay? And the way you can know there's a problem, apart from when your teacher puts a heading on the board that clues you into that fact, is, well, let's muck around with this a little bit. If I put this into a more standard form, okay, which admittedly is not much of a change, what can you tell me about this parabola? Specifically, how is it different to this parabola? Can we compare these two? All right, number one, there's a shift, okay, and it's shifted down. That y plus 2 means the vertex is no longer at the origin, right? The vertex is here, actually, that point we got given before, okay? So there's the first thing, a shift. Secondly, I had a coefficient of 4 here. I have a coefficient of 2 here. What difference does that make?
It's steeper.
It is steeper, right? It's steeper. There's a couple ways to think about that. Number one, it means the focal length is smaller, okay? Which also means the, and I hate having to say this, but it happens every year, the latus rectum is thinner, right? It's thinner because it's based on the focal length, okay? So if this was that width before, because that's a 2 now, it should be half the width. It's a thinner, steeper parabola, okay? So here's what I've got. Let me get another color. It's been moved down and it's steeper. So I'm getting something like this. Okay. That is, I should write it on there, x squared equals 2y plus 2. Okay. So you tell me, what's the problem?
But if it's midpoint of Pq, how come it's like down there?
Good question.
Is there a good answer?
There will be in about 60 seconds. What's the problem? Can someone state it for me? Let's just into a...
Midpoint of the chord has to be inside.
Good. Okay. So whatever chords you draw, okay, let's just have a messy parabola over here. Yeah, I don't know where he's going, okay? Or once you take all those chords, okay, and you take the midpoints of those, the thing they have in common is all the midpoints are inside the parabola, okay? And yet we've got this weirdo section out here, which matches our equation, right? But it clearly can't be part of the locus. Okay? Clearly can't. So that's how you know there must be some restrictions. Yeah.
Why does the equation give you that?
Why is the equation given to you? Because the parts that I do want, they do, sure enough, line up on this equation. Okay.
Yeah, no, I mean, once you've gotten the parametric coordinates of the midpoint,
Yep.
and then you eliminate the parameters, why do you get a parabola that's outside? Why is algebra not right?
Yeah. Okay. I'd probably say because algebra, all of this stuff that we're doing here, all this manipulation, right? It's never enough to tell you which answers are right and which ones are wrong. A little bit like, you know when you're doing absolute value, right? And you're solving one of these things, like bounce and then, you know, bounce, something like that, right? Algebra will give you answers, but it will give you more answers than there are, right? And you do everything correct. That's when you got to do cases, you got to test it out, or you look at the graph and you're like, well, that's not an answer because even though the algebra told me one, it doesn't line the graph, okay? So algebra is never sufficient on its own. That's why I drew it, actually. Question?
How do you, where's the restriction on the graph? You know how you said you crossed out the bit underneath that y is equal to 0?
Sorry, not quite. There's actually a bit above y equals 0, like see this little shade in there. Okay, so, but yeah, underneath there, I've crossed it out.
Where did you state the restriction in the question?
I haven't yet. I haven't. Now here's the thing, okay? Here's the question. Here's the length and breadth of the question. That's all we said, right? I might have said, state any restrictions. Okay? But here's the thing. They don't tell you what the restriction is. You have to find what they are, right? And the nature of the question, that it's the midpoint of a chord, that makes you think, okay, there must be some kind of restriction on it. Now the question is, what is it? Okay?